Hello students, so let's try to solve one more problem from IIT JAM 2022. This problem is from quantum mechanics, a one-dimensional infinite box. So it is given that box, the particle is confined between minus L by 2 to plus L by 2, and this is infinite box. So I can assume this is my infinite box between minus L by 2 to plus L by 2, and we have this is, and the wave function is given psi x, and this is root 2 by L cos pi x by L. So we can easily recognize this is ground state wave function. And if it is ground state wave function, the corresponding energy is pi square h cut square upon 2 ml square, because L is the length and this is centered about 0. So now we have to calculate uncertainty in momentum and uncertainty in position. So the option is given so beautifully such that we have to only calculate uncertainty of momentum. The other option will be come directly from the basic concept of this particle in box. So first we have to calculate uncertainty in momentum because it is easy to calculate. So uncertainty in momentum, we have delta P is equal to expectation value of P square minus expectation value P whole square. So we know that for this state, expectation value of P is equal to 0 because this is ground state, and this is superposition of two momentum state which will go from left to right and right to left, and the weight of these two state will be same. So why momentum, expectation value of momentum is 0. Now we have to calculate expectation value of P square. So without going to integration, we can easily calculate that expectation value of energy is equivalent to expectation value of P square upon 2m. So from here, the expectation value of energy is basically the eigenvalue because it is just an eigenstate. So we can easily calculate this thing. So pi square h cut square 2m L square, and this is expectation value of P square by 2m. So we can easily calculate the expectation value of P square is equal to pi square h cut square upon L square. So when we will calculate delta P, the delta P is equal to, basically we have to do the root of this thing, and this value is pi h cut upon L. So obviously only in two options we have pi h cut upon L, into option A and option C. So we have to check whether what will happen to delta x now. Obviously this is neglected and this is also wrong answer. So now let's go for expectation value of delta x. Sorry, we have to calculate uncertainty in delta x. So when we are going to calculate uncertainty in delta x, then we have to find these two values. So delta x is equal to basically expectation value of x square minus expectation value of x whole square. And we can see this is symmetric about x is equal to 0 for the ground state. So we can easily write expectation value of x is equal to 0. And now we have to only see that what the delta x is nothing but the root under expectation value of x square. Now, when we are going to calculate expectation value of x square, then obviously we can easily see the whole integration is given by the expectation value of x square is 2 by L normalization constant x square, and that is cos square pi x upon L dx minus L by 2 to plus L by 2. And this integration is even integral, which is not equal to 0. So expectation value of x square is not equal to 0. Now we can see the other option without doing this integration and without seeing this number. Hence B and D is not a correct answer due to expectation value of, due to this particular delta P is given, we have calculated that is pi h cut upon L. So only A and C can be possible correct answer. And hence expectation value of x square is not equal to 0. Then delta x is also not equal to 0. So this option is also wrong. So yes, only one option left, and that is this one. Delta P is equal to pi h cut upon L, and delta x must be greater than L by 2 root 2. So this is our correct option, and without doing integration, with the help of concept, we can easily give the solution of this particular problem. So it's a very nice problem, and we have done this problem in our class, everything we have discussed. So how we can go for this, but for the next exam, I will suggest for everyone that please try to calculate this integration also. Maybe in the next exam they will give you the what is the exact value, and they can give such a number where delta x is equal to not 0 here also and here also. Anyway, and it's a very simple but tricky question. Thank you.